Good morning, student. Today we will discuss the new chapter, that is pH, buffer and isotonic solutions. In this chapter, firstly we have to discuss about the pH. pH, that is represent the hydrogen ion potential. So it is defined as the negative logarithm of molar concentration of hydrogen ion. The pH term was first used in 1909 by Sorensen, and in pH, the P in pH denotes the potential, means power in Danish, and H stand for the hydrogen. So H is written in a capital letter. According to the thermodynamics, the pH is defined as the negative logarithm to the base 10 of hydrogen ion activity. Now next, about the Sorensen pH scale. In 1909, the Sorensen coined the term pH to represent the hydrogen ion potential. So the Sorensen defined the pH of the solution as the negative logarithm of hydrogen ion concentration. The concentration of hydrogen ion measure of its acidity or basicity of a aqueous solution at specific temperature. The acidic solution have higher relative number of H positive ions, while alkaline and basic solution have a higher relative number of OH negative ions. The pH scale range from 0 to 14, and the scale start with a 0 pH that indicate the solution is strongly acidic, and other end of the scale pH is 14 indicates the solution is strongly alkaline. The central point of pH scale is neutral. The reason with pH value below 7 is designated as a acid, and above pH 7 is designated as a basic. At room temperature, the neutral solution has a hydronium concentration of 10 to the minus 7. So next, classification of acid and base based on the pH scale. According to the Sorensen pH scale, acid and base are classified into the following types. First is a strong acid. The acid whose pH range between 0 to 3 is known as a strong acid. For example, hydrochloric acid, sulfuric acid, nitric acid. Now second is a strong base. The base whose pH range between 11 to 14 are known as a strong base. For example, sodium hydroxide, potassium hydroxide and barium hydroxide. Now third one is a weak acid. The acid whose pH lies between 3 and to the 7 are known as a weak acid. For example, carbonic acid, acetic acid and phosphoric acid. And fourth category is weak base. The pH lies between 7 to 11 are known as a weak base. For example, ammonium, methylamine and sodium bicarbonate. Now next is a calculation of pH by proton valence equations, and this equation based on the Bronsted-Lowry theory of the acid and base. According to this theory, total number of proton donated or released by an acid that must be equal to the total number of proton accepted or consumed by a acid. In proton balance equation, the sum of concentration term of species formed by proton release is equal to the sum of concentration term of species formed by the proton consumption. In this equation, the following steps are required to calculate the pH. Step 1. Start the proton balance equation by taking consideration the species added to the water. In second step, place the concentration term of all the species that are formed when proton are denoted by the starting species on the right side of the equation. In step third, place the concentration term of all the species that are formed when proton are accepted by the starting species on the left hand side of the equation. In fourth step, multiply each species by number of proton denoted or accepted by a starting species to form the new species. And step fifth, in the right hand side of the equation, the hydroxyl ion, and to the left hand side of the equation, add hydronium ion, which results in the interaction between two molecules of the water. Now taking one example to calculate the PPE equations. In first step, start the proton balance equation for hydrochloric acid in water as firstly start with hydrochloric acid because it is a starting molecule. In second steps, place chloride because it forms when HCl denote a proton. In step third, the hydronium ions forms because it is formed when water accept a proton. In step 4, the equation involve only on one transfer of the proton from the starting molecule and there is no need of the multiplying. Now add hydronium ion to the left hand side and OH negative ion to the right hand side of equation. So overall equation are become as a hydronium ion is equal to the hydroxyl ions plus chloride ions. Now next is the measurement of the pH. The pH value is measured by the following method. First is a pH paper method, second is electrometric method, and third is colorimetric method. Firstly, pH paper method. For routinely work, the pH of solution is determined by the pH paper. The pH paper of both broad and close range are available, and the color of pH paper changes with the according to pH, and the color produced in contact with the solution of different pH are given on the reel of the paper. Now little bit procedure for the pH paper method. Take 10 ml of sample in a clean or dry test tubes and take a piece of paper with a pair of forceps and partially dip into the sample and compare the change of the color with the color chart and record the range of the pH. So this is the quickest method used in a pharmaceutical field. Now second is a electrometric method. This method is widely accepted method for the determination of pH. The principle for this method is it is based on the principle that when two solutions are separated by a thin glass electrode membrane, a potential difference develops between the solution in the valve and solution outside the valve. So difference in the electrical potential is proportional to the concentration of hydronium ion of the solution being measured. Now apparatus used in a electrometric method, pH meter. Second one is a measuring electrode. That is a glass electrode consists of a glass tube which is sealed at the end of the thin walled glass bulbs, and the glass bulb is made up of lithium glass which is suitable over entire range of a pH. Next one is a reference electrode. The reference electrode is used as a calomel electrode and it has a glass envelope that contain glass tube containing calomel, that is mercury and mercury chloride. which is bathed in a solution of potassium chloride, and the reference electrode provide constant potential. When the glass electrode is immersed in a test solution, the potential difference developed between the solution in the glass valve and test solutions. Now come to the procedure. Connect the glass electrode to the pH meter and adjust the electrical zero of the pH meter. If required, adjust the temperature of pH meter to the solution temperature. Now standardize the pH meter by immersing the electrode into standard buffer solution of pH 7 and adjust the potential knob till the meter reads the known pH of the buffer solution. Now next, further calibrate the instrument using pH 9 buffer solution and pH 4 buffer solution. Wash the electrode with water and dry. Now dip the electrode into the test solution whose pH has to be measured and stir the solutions to ensure the homogeneity and minimize the carbon dioxide entry. At the end, note down the pH reading from the pH meter. Third method is calorimetric method. Calorimetric method is used to estimate the pH of a solutions, and it is based on the principle that the color or chemical indicator change in a sample due to the amount of hydrogen ions. The color is either due to the inherent property of constituent itself or due to the formation of color compound as a result of addition of an indicator. Now come to the procedure. In this method, initially an approximate pH range is identified and then the procedure is repeated for obtaining a pH range. Firstly, prepare the standard solution of non-pH value which is ranging from 3 to 11 with 1 pH intervals. Now add a few drops of universal indicator to the each buffer solution and observe the different color changes. Add a few drops of universal indicator to the test solution so that it also develop a color based on its pH. Observe the color change in the test solution and match it against the color produced by buffer solution, and the pH of test solution must correspond to the pH of buffer solution which is having same color shaded, and based on the approximate pH value obtaining that, reduce the pH interval to a narrow range. Okay, repeat the steps 2 and 4 to obtain the actual pH of the test solution and report the exact pH of the test solutions. Now advantages of this method: it is simple or less expensive, and acid base reaction in non-aqueous solution can be studied. Now next is a application of pH. The application of pH mainly to enhance the solubility and to increase the stability of the drug and to improve the purity of the drug, and it enhance the biological activity and it provide the body comfort, and it is used for the storage of the drug product.